Today we're going to continue looking at dimensional analysis in the form of what we would call Dimensional Analysis Olympics. It's simply going to be a small challenge that you're going to be working on over the next few days. It's going to give you a chance to practice working on the concepts that we've been discussing related to dimensional analysis. So with that in mind, I wanted to spend a few minutes talking to you about what the expectations are, give you some ideas of what you're going to be doing as you're moving throughout the classroom for this small activity, and then just give you one example, because I know that as you're getting started on this, some of you are going to find this to be rather challenging, and so it's just to kind of get you set up so that when you get started that you feel a little bit more confident. Now with that in mind, you should have received a dimensional analysis paper. Make sure you have one. It should have two papers attached to it. It should be a dimensional analysis sheet, and then behind it should be a data page. So if you would just take a minute right now and make sure you have both. Your dimensional analysis sheet is going to look something like this, and it should go through and talk to you about the objectives, materials, group procedures, and everything you're going to be doing as a part of the lab. The other thing you should also have attached, make sure you have, is a data page. It looks something like this. It says Chemistry 1 Dimensional Analysis Data Page. You'll see a spot for your name, a spot for your partner's name, the block, which is period, and then a spot for all your work related to each event. If you would just take a minute right now, and on this page, your Dimensional Analysis Olympics data page, if you would find the spot for your name and go ahead and put your name, and then below that, go ahead and put whoever your partner is. So if your partner, which should be your lab partner or the person you've been working with thus far this year, just go ahead and write down their name, and then block number, go ahead and put what period you're in. So first, second, fifth, or seventh. Just go ahead and make a note of that for me, please. Once you've done that, go ahead and flip back to the first page of this activity, and we will get started. Okay, quickly, so the main objective of this activity is to gather information using problem solving, as well as to set up conversion calculations with dimensional analysis. So it's doing a little bit of some things that we've already been practicing doing, or hopefully been practicing doing as we've started the year, but then it's also adding in the idea of dimensional analysis, how it is that we use that process of organizing our information and then setting up a calculation ultimately to solve a problem. Now, some of the materials that you're going to find throughout the classroom to use as you're doing this activity include Tootsie Rolls, Hershey Kisses, meter stick, triple beam balance, stopwatches, and then anything else that you might think of that you might need, like a calculator, extra paper, pencil, things like that. If you notice, and don't get up and walk around just yet, but if you notice throughout the classroom, you're going to see that the events are already set up. So it's going to say event 1, event 2, and there's going to be the materials you need already there for you when it's time to get started on the lab. Now, a little bit about this activity. So this activity is completely independent, which means that you will not be timed. You'll be moving around as you're working on the activity at your own pace, which means take as much or as little time as you need at each station in order to complete it. Some of the stations are going to be harder than others. Some of them you might get through relatively quickly. Others might take you a little bit more time, and that's okay. Again, because you're working at your own pace and because you're moving through the stations independently, that means you can start and end wherever you want. So if you want to start at station 1, that's fine. If you want to start at station 5, that's fine too. The only thing I would ask is that you move to a station where there's not a lot of other groups at. If you could kind of spread yourselves as you get started on the activity throughout the classroom so that everyone can move freely and get the activity done. The stations that require you to do some sort of movement, like jumping or hopping or something like that, I made or put towards the door so that if you needed to, you could step into the hallway and do these tasks. The only thing I ask is that you remain quiet and that you observe all classroom behaviors in the hallway just like you would if you were in the classroom. With that in mind, if you will just notice a little bit about what your expectations are. So under groups, you will be in groups of 2, as I already said. You're going to perform each activity, so each event, and collect any data needed. Each problem that you do will be worth a total of 10 points. So if you think about it, there's 5 events times 10 points for a total of 50 points for this assignment. Then you're also going to be scored in an effort to basically win Dimensional Analysis Olympics. I will go through and I will look for every single detail, including all of your knowns, unknowns, including your relationships, your conversion factors, your work or conversion charts that we've been looking at when we set up dimensional analysis, and then finally your answer, as well as units and sig figs. If everything is correct, then for each problem you'll receive more points, which will add up to a total score that you and your partner will get. The group that receives the highest score will receive 10 MOL. The next highest score is 5 MOL, and the third highest would be 2 MOL. Simply, you will receive either gold, silver, or bronze based on who has the highest 3 scores in the class. Now, this will be per class, so don't think you're competing against everyone in all of my classes, but you're simply competing against all groups in each class. If there would be a tie, then the MOL will be split evenly. If you should have any questions about that, please feel free to ask. Okay, so let's take a look at what you're going to be doing as you conduct these this procedure. Simply put, these are the steps you're going to follow. So you'll simply go from event to event. You're going to read each of the questions. You're going to determine how to collect the data you need for each problem. You'll complete the activity and collect data as you complete it. You're going to use dimensional analysis with your data to make calculations and answer the questions provided. Again, you'll be given 2 days in class to complete the experiments, and then your final lab analysis paper will be due to me. That would be your data sheet will be due to me on Friday, September 15th. Now, this is different from what it tells you on the paper itself. Your paper, I believe, tells you the next Friday, Friday 26th or something like that. But go ahead and mark that out and make a note that your data page will be due to me by Friday, September 15th. Now again, what that means is this page right here, the Data Dimensional Analysis Olympics page, data page with your name and your partner's name on it. This will be due to me by Friday, September 15th. No late work will be accepted, so please make sure you turn it in to me by that day. Now, we're starting on it today. Obviously, you'll have a couple days to work on this. Depending on how much time you use today, we'll control how much extra time you might get. So please make sure you're using your time wisely. So going back, as we're conducting the experiment and as you're looking down through, you're going to notice that each event has some questions, has some steps it asks you to follow, and you're simply going to do that. But because I realize that some of you might have trouble getting started just because, you know, you haven't done anything like this before and dimensional analysis is still new to you, I wanted to go through the first one with you and just give you a chance to see what it looked like. So if you would, turn your page so that you are at event 3. Event number 3. Event number 3 says hopping good times. You'll notice that there's some steps that it's going to ask you to follow. And I wanted to go ahead and complete this event with you, or at least talk to you about how you would go about completing it. So I went ahead and did the task myself and basically followed the directions, and I wanted to show you what it would look like as you're setting it up. Now again, y'all, this is going to be my work, this won't be your work, but this will give you an idea of what to do as you're following this event, and that hopefully will get you started at least maybe to do 1 or 2 events today, and maybe move you forward into doing some more tomorrow as well. So let's just start at the beginning. Event number 3, it says measure how long it takes for you to hop 1 meter. So you're going to notice when you get to event number 3 that there are meter sticks provided, but I went ahead and hopped 1 meter, and when I hopped a meter, I found that it took me 1.06 seconds. So 1.06 seconds, and that took me to hop 1 meter. Alright, so 1 meter in 1.06 seconds. Alright, so I did that. It said next, it says calculate your hopping speed in meters per second. Now, y'all, maybe you don't remember speed, or you know, maybe you didn't. I mean, I know that you've learned speed because you probably did it in elementary school and maybe a little bit in middle school. But because you might not remember what speed is, it goes ahead and it tells you, right? It says that you're going to be calculating it in meters per second, which really is just like saying distance over time. And it tells you that your distance is in meters and your seconds is time, right? So you already have the information you need. It's just a matter of plugging it in. So we've got our distance, which is 1 meter, and we have our time, which is, in this case, I said 1.06 seconds. Alright, so we could calculate that, right? I could simply take Alright, so we could simply calculate that. I could take 1 meter divided by 1.06 seconds, and I would find that my speed was 0.94 meters per second, 0.943 to be exact. Now, I say exact, I simply mean based on sig figs. 1 meter is an exact measurement, right? We used a meter stick, so I hopped exactly 1 meter, but the time was measured, which means I measured that I hopped 1 meter in 1.06 seconds. While this might be an exact number, this is a measured value. So that would be where I look at my sig figs, right? So 1.06 has 3 sig figs, which means my meters per second would be in 3 significant figures. All right, so I calculated my hopping speed in meters per second. Now, that would be like one of those calculations we talked about a couple days ago where we would be simply solving for x, right? We solve for x by finding that speed was 1 meter over 1.06 seconds. All right, next question. How many hours would it take you to hop from Shreveport to Dallas? Now we've got a story problem, right? We've got a problem where we have a known, which is something that's given to us somewhere, and then an unknown, which is the question, right? So let's talk about and set up, using the idea of dimensional analysis, how we would solve the problem. And remember that we always set up by first identifying what are known and unknown, what they are, right? Now, in the known in this problem might be a little bit hard to figure out, so we're going to come back to that one. We're going to do the unknown first. Remember, the unknown is always the question, and in this case, the question says, how many hours? So the question is the amount of hours, right? Alright, what about the known? Now remember, the known is given, right? So it's got to be quantitatively given to us in the problem. Now remember, it says, how many hours would it take to jump from Shreveport to Dallas, right? So what are we given in relation to Shreveport to Dallas? And it's right here. That is our known. We know that we're going 188.11 miles. All right, so we've got our known, we've got our unknown. All right, what's the next step? The next step is to identify any relationship. So is there a relationship between our known and our unknown? And you should probably say no, right? Because that's what we're solving for. We don't know a relationship between miles and hours. But there are some relationships that we do know. So let's just think about some relationships we have. Now, one of our relationships we actually already came up with today as we were doing the activity. It should look really familiar. That looks like a relationship, right? Because it's saying that one thing equals another, because it does. So one of our relationships could be, and at least for me, that 1.0 seconds equals 1 meter, right? That was how fast I could hop 1 meter, right? How fast I could hop 1 meter. So that's a relationship. Are there others? Absolutely. So let's think about some other relationships we have. Like, for example, we don't know hours and miles, but we do know things like hours and minutes, like 1 hour equaling 60 minutes. We do know minutes and seconds, and that could be important, right? Like 1 minute equaling 60 seconds, because that allows us to relate. Do we know anything with miles? Well, you might not, at least not off the top of your head right now, but as you're doing the activities, you're going to see that I think it might be, I can't remember which event, you'll have to look back as you're starting, but in one of the events, it actually gives you the relationship between miles and meters, and it tells you that there's approximately 1,600 meters in a mile. Alright, so those are our relationships, right? Notice that we've got miles and meters. Notice we've got hours and minutes. We've got minutes and seconds. So we're going to have some relationships that are going to allow us to get from miles, which is what we know, into hours, which is what we don't know. Now, again, I kind of helped you through this one, y'all. As you're starting on some of the others, you might struggle a little bit because you might have trouble being able to connect what things are or how things are related, but that's where the whole process comes in of you practicing it and you thinking about how they're related and you problem solving. So work through it, y'all. Do the best you can, but then also don't hesitate to ask questions because it's not always going to be extremely easy. Alright, so please don't get discouraged if you find it to be somewhat complicated, but just work through, problem solve, think about how things are related. Alright, so we've got all of our relationships, so let's just get started on using them as conversions. Now, I can go ahead and write them out as conversions for you, so you think about your relationships. You've got 1.06 seconds over 1 meter, or 1 meter over 1.06 seconds. We've also got 1 hour over 60 minutes, or 60 minutes over 1 hour. We've got 1 minute over 60 seconds, or 60 seconds over 1 minute. And then our last one, which I just gave you, 1 mile over 1,600 meters, or 1,600 meters over 1. Let's put all of this together and let's get our conversion. This will ultimately give us our final answer. So let's start again. Remember, with a conversion, we start with our known. So our known in this case is 188.11 miles. Remember, we're going to write that over 1. Now we're trying to go to our unknown. So our unknown is we're trying to go into hours. And now we need some steps, right? Some steps we're going to follow that will allow us to get from 1 to the get into hours. We don't have a relationship between miles and hours, but we do have a relationship between miles and meters. And why could that be important? Well, we think about it. Remember that we found that for every 1 meter, it would take us 1.06 seconds. So if we were in meters, we could use that, or the idea of that, to convert to a time that would get us to hours. So let's go ahead and let's use our relationship between miles and meters to get rid of those unit miles and give ourselves meters. So let's start with, if miles is on top, miles is going to need to be on the bottom, which means based on that, we're going to use the relationship where meters is on top, so 1,600 meters. And that's going to allow us to convert from miles into meters. But meters wasn't what we were trying to solve for. Remember, the question is how many hours. So we're going to need another relationship. We're going to need something else that will allow us to take those meters and go to something else. Notice the only relationship with meters in it is meters and seconds, right? We figured out our speed, which we said was 1 meter is 1.06 seconds. So let's set that up. We need our meters this time. Meters on top, so we need meters on bottom. We need our seconds, which was on top. So we've got 1.06 seconds in 1 meter. Our meters cancel, and now we're left in seconds. But again, that's not what it's asking us to solve for. This is asking us to go into hours. So what do we do from here? We were in seconds. We need to get rid of those seconds. So we need seconds to be on bottom, which means we're going to want minutes on top. And for every 1 minute, there's 60 seconds, right? So now we're in a new relationship. We're in minutes, but we're not done. We're trying to go into hours. So what are we going to do? Well, minutes on bottom. So 60 minutes. Hours on top. 1 hour. All right, so now notice that what we've done here, and again, let me clean this up a little bit. So let's get rid of some of this other stuff so that you can just have what you're looking at and make sure you see what's going on. But notice what we have here, right? So notice we've got our dimensional analysis set up. We've got our miles, we took to meters. We got our meters, which we took to seconds, seconds to minutes, minutes to hours. And that's what we were solving for, right? So without realizing that we could have, we're able to take that 188.11 miles and we're able to convert it into how many hours it would take. That's dimensional analysis. Now this should, setup-wise, look very similar to what you did yesterday when you were asked to figure out how many seconds are in a year, right? And so you had all of your setup and you started with your known and you went into your unknown, and that's exactly what we did here as well. Now again, I realize that this might look a little tricky and you might be thinking, I don't know if I could do this for all the others, but I'm going to ask that you at least try. Try the setup. Try to see if you could go about solving the problems based on solely following these steps that are given and then following those dimensional analysis setups. All right. Now, with that in mind, go ahead and solve this. See if you can figure out how many hours it would take for me to go 188.11 miles. So just take a minute, see if you can solve this dimensional analysis calculation, and then we'll go from there. Alright, upon completion of solving, remember that the idea of dimensional analysis means that you're going to multiply everything on the top and divide by whatever's on the bottom. So as you look, you'll notice you'll end up taking those miles, multiply by 1600 times 1.06, and then divide by 60, and then divide by 60. Now when you do that, you should get something like this. You should get 88.6 hours. Now notice how many significant figures I have. Actually, we're going to end up rounding that because of sig figs. So we're going to end up rounding it to 89. Now understand why. Alright, so if we start over here at the beginning, this is a measured value with 5 sig figs. But this is also a measured value, right? Remember we said that that was an estimated value, that was approximately 1600 meters, and that only has 2 sig figs. Also a measured value with 3 sig figs. And then remember that these are exact amounts, which means they have no significant figures. So as we're solving this problem, since we're doing multiplication and division, which is the least amount of sig figs, then that means 2 is our least amount. So in the end, when we round it to 2 sig figs. So 88.6 becomes 89 hours, and then that would be it. We would be done. Now before you get started, y'all, again, I realize that you're going to have a lot of questions as you're going through, and I encourage you to ask Ms. Golson as needed, but also at the end of the day today, upon completion of at least trying to do one, maybe set up some information for a few different events or stations, at the end of the day today, I would like you to take a half sheet of paper or a post-it note or a note card, and I'm going to ask that on that you write down one thing that you would like to see before you start continuing to do it the next day in class. I would like to have an idea of what you're getting or still not getting as you're continuing working on it and you get ready to do the activity on Monday as well as Tuesday of the next week. Now with that in mind, y'all, please don't just say I don't understand, because that doesn't really help me in being able to help you. So be very specific about things that you would still like to see as you are moving forward with this. Now, I'm only going to be able to spend about 10 minutes doing a small video with you at the beginning of class on Monday before you continue working. But anything that you have beyond that, please don't hesitate to also send me a message, you know, via email or maybe on Remind if, you know, there's specific questions you might have. Reminder, the final data page, completed data page, will be due to me on Friday of next week as you enter the classroom. You're more than welcome to turn it in to me before then, but if you do not finish it in class on obviously today or on Monday or Tuesday of next week, and you'll get all the period on Monday, you'll get maybe a small portion on Tuesday, but if you do not finish it in class, it will become something that you'll have to make sure you get done on your own, because the final paper will be due to me when you walk in the class again by Friday of next week. If you should have any questions, please don't hesitate to ask, and that's it. I hope you have a great day.